Hi, welcome back to our Honors Geometry playlist. On this video, we're going to take a look at how do I prove a geometric proof involving the segment addition postulate. So the first thing I should always do is, of course, copy down my given statements. Given that ij is congruent to jk, and if you want to do that in one step, you can do that. If you want to break it up into multiple steps, you can do that as well. I'm just going to change colors. Hi is congruent to KL. So those are my given statements. First thing you will always want to do is your given statements. Next, if I had any vocabulary words, whether that's linear pairs or vertical angles or midpoint or bisector, something like that, where I've got a word that I can define, some vocabulary word in my given statements, I would maybe look at that next, but I don't have any vocabulary words in there, just congruent segments. So next, let me take a look at my diagram. Does that show me anything that I can assume so far? And nothing is marked, so I can't assume anything. I can't write any given statements from there. And since I have a segment or a series of segments that are connected, I'm going to try my hand at the segment addition postulate. But what segments should I write an equation for? Well, to know that, let me take a look at my prove statement. What segments do I really want in my equations? I want hj and jl. So I'm going to write the segment addition postulate for hj, which says that if I were to add up hi plus ij, I should get hj. And now you could also, in the same line, write the next segment addition postulate equation for jl, but because I'm trying to write a little bit bigger here, let me do that in a third step. So jk plus kl equals jl. And both 2 and 3 would be my segment addition postulate. Okay, so I did my givens, I checked for vocabulary words, I checked my diagram for given things, couldn't find anything. I did my segment addition postulates. Now, really what I want to prove is that those two segments, hj and jl, I want to prove that those are equal. So if I want to prove that those two segments are equal, that the right side of the equation is equal, well, if the right side of the equation is equal, what else should be equal? If the right sides are the same, then the left sides should also be the same. So the rest of my proof is going to be dedicated to trying to make these two expressions exactly the same. And I'm going to substitute in some of my equal segments or congruent segment from the given into one of these equations. Now, it doesn't matter which one you change and which one you leave the same, but I would encourage just changing one. Just focus on one. So I would really like jk and kl to change. I'd like those to really say hi and ij. So I'd like jk to be gone. But if I look at my given statement, what could I substitute in? What could I write in instead of jk? Well, instead of jk, I could write ij. Okay, so that's going to be gone. That's good. I really don't want kl because it's not part of the other expression. So instead of kl, what could I write? Instead of kl, I could write hi. And I'm going to stop there for a moment. So what I did was I substituted some known values from the given statements in for JK and KL. I changed those segments. So instead of JK, I put IJ because it told me that I could in the givens. Instead of KL, I put HI because it told me that I could do that in my given statement. And now let's take a look at our segment addition postulate problems one more time. I'm going to erase a lot of this stuff for now. What do you notice about my two segment addition postulate equations now that I've used substitution to rewrite the second one? I have HI plus IJ, I have IJ plus HI. Well, really, what could you say about those two expressions? I know that they're switched, but they really are the same thing, right? I could say 2 plus 5. It's the same thing as saying 5 plus 2. It means the same thing. So these two expressions, the left sides of the equations, are equal. Well, if the left sides are equal, then what do I know? If the left sides are equal, then the right side of the equation must also be equal. And I'm trying to get that step 3 back. There we go. So from step 2 and step 4, I can say that, maybe I should go back to the original color. I can say that HJ equals JL. And I can only say that because this stuff equals HJ and this stuff also equals JL. So HJ and JL are equal to the same thing. The left sides of the equations are the same thing. And because the left sides are the same thing, I can say that HJ and JL are equal. But I do have one more step. So this could be either transitive property, or I would also accept substitution. I said they were equal, but I really want to prove that they are congruent. So my last step, I would say that those are congruent segments by, well, how do I know they're congruent? Well, what does it mean to be congruent? It means that they are equal. So by the definition of what it means to be congruent, those segments are congruent. I'm going to put one more video up that's a little bit shorter as well. That way you can pick one, watch it. If you want more examples, watch the other videos as well. And